Hey everybody, welcome to another fun episode of Hacking Hubs. I'm your host Greg Fodor, and today I'm working on a prototype of a potentially new WebRTC SFU adapter, and I'm kind of in the middle of it, so I figured it was kind of a fun thing to maybe stream about, and so I'm going to be doing that, and we'll see how it goes. So I'm working on experimenting with another SFU. Oh, and Gabriel's in the chat, and Gabriel kind of tipped me off on checking this out. So there's another SFU, WebRTC SFU that I did a little bit of exploration on, and WebRTC SFU is the server we use for sending voice and video streams between users and hubs. And currently we're using an SFU called Janus Gateway, and we've had a lot of luck with that. However, there's a number of other features we kind of are interested in. One of them, for example, is WebRTC Unified Plan, and that's something that right now Janus doesn't support. And so kind of regularly I peek in and see what's going on in the wider WebRTC ecosystem with regards to SFU development. And Gabriel in the chat there tipped me off to check out, see what's going on with Mediasoup, which has been a long time SFU open source project. And it's been moving along very rapidly, and I was really encouraged by what I saw in terms of its kind of functionality and stability. And so I figured it might be worth a few days to just take a stab at seeing how it might go if we try to plug this SFU into hubs and see what surprises it might yield. So so far what I've done is I set up a basic capacity test on Amazon over the weekend that kind of just stood up a basic SFU test, and I threw some load at it and just kind of wanted to do a sanity check to see how it looked. And it was very encouraging. The results I saw were enough for me to get to the point where I felt like it was worth pursuing a bit further. And so that's what I'm doing now. And so this is going to be probably a little bit messy because I'm really in the middle of hacking on it, but I figured it might be a fun thing to go through. So the way our integrations with SFUs work is we use a framework called Network Dayframe. And Network Dayframe is something you can find, it's an open source project. It lets you do game networking and WebRTC voice sharing through the browser. And it provides a nice interface for creating what are called adapters, which is basically a plugin architecture for being able to swap different networking backends, such as an SFU, different kind of SFU out in order to switch what it's using underneath for these kinds of facilities. And so we've traditionally been using an SFU adapter, a NAF Janus adapter called NAF Janus adapter, and that's what I have at the bottom here. And so this has evolved over time to become fairly stable, and this is a adapter that's specifically used to enable Janus as the SFU backend for the voice transport. And so I've been kind of going through the process of hacking through and trying to get a basic V1 together for this Mediasoup SFU. And the kind of three relevant pieces of code I'm using to do that is our NAF Janus adapter, which has a lot of really robust functionality and generally implements the API in a good way for Janus. And then I'm also using this Mediasoup demo app, which is also an open source MIT licensed app that is kind of the reference implementation of a Mediasoup client and server. And so I've been using that as a kind of sanity check to try to, I'm basically kind of going through and surgically removing pieces of this and then moving it into the NAF dialog adapter, which is the new adapter I'm working on. And then in addition to that, I'm referencing just the wider hubs code and so on to kind of get an understanding of where all the API calls are, because I'm a little bit rusty on this part. And so to give you a kind of update on how far I've gotten with it, so I have the basic kind of connectivity working with just getting the initial WebRTC connection stood up and sending audio data. And I'm kind of on the verge of getting video data to be sent. So my approach is going to be to get just pure publishing working first, just sending data correctly first. That's kind of an easier thing to do because you just need one client running to implement that. And then the consumption part I'll do next, which basically will be, require two clients to be running. So when you, so to just show how far I've gotten so far, so if I go into my WebRTC debugger you can see that on the landing page, there's no negotiated candidates. And this is actually kind of nice. So the API that Mediasoup provides is a bit higher level than the API I'm used to working with. So it actually abstracts away a lot of complexity around peer negotiation and things like that. And so in fact, at this stage of things, the client has actually joined the room on the signaling server, which I'll show it maybe a little bit later. But basically, there has yet to be any WebRTC negotiation because there's been no data to be sent over the transports. So on the client, there are these conceptual transports, and I can show you kind of negotiation of those or the setup of those. So basically, there's an entry point here, join room, and this is effectively equivalent to the join room. Oh, sure. So yeah, so I'm just taking an off-the-shelf signaling implementation that also is part of the Mediasoup demo. And for our purposes, that's fairly sufficient for a V1 implementation. There's a number of to-do items I will have to do after the fact once I get the basic end-to-end functionality working. I have a pretty long list of things I need to do, both in terms of testing things, and then also there's additional functionality we'll need to implement to the SFU. But the out-of-the-box demo SFU is enough to get a basic signaling protocol going so you can have peers and talking and that kind of thing. So yeah, so I think this probably will be generic. So far, it's really going to be a drop-in thing. So we'll see how it goes. Oh, whoops. Sorry, thank you. So for join room, I'll just walk you through the flow I have working so far. And a lot of this I'm not going to take credit for. A lot of it is just me kind of surgically grabbing stuff from the Mediasoup demo app. And so Mediasoup abstracts over all of these device capabilities. So for example, it will be able to look up your codecs and things like this. So it does all of that and just kind of packages it up into an encapsulated capabilities array, which is used for the initial SDP negotiation when it eventually happens. And then, and I just commented this out for now because this is about some autoplay stuff I'll revisit later. And then basically you create two transports. And now, as I mentioned, we're really interested in getting support for unified plan. And what unified plan is it allows you to only set up two logical peer connections between you and the WebRTC server. And so that means that you're only going to do ICE negotiation twice. I am not a WebRTC expert, but I presume there's probably some other things beyond that only are going to happen twice now. Whereas in our current situation, because we're not using a unified plan-based SFU, every time there's a peer connection that needs to, or anytime there's a new consumer subscription that needs to get created, we have to go through a full ICE cycle to negotiate that and all that jazz. Now, we still have to do an SDP exchange. You know, one of the things we were seeing with Janus is that if there's a significant amount of subscriptions happening concurrently, there's some CPU bottlenecking that can occur in the SDP negotiation part. And so, you know, my limited load testing seemed to imply that's not the case for Mediasoup, but I don't want to get out ahead of myself. I won't really know that for sure until we have a kind of working implementation that is at feature parity, and then I could do a real integration test with a load tester. And so, anyhow, we have these transports. These are logical transports in the sense that they're that they're basically lazily going to be creating the underlying ICE connections. Or the negotiated peer connections through ICE, but they don't actually get negotiated until you start to try to produce and consume. And so the API is quite clean for the Mediasoup client. So this is using the Mediasoup client API, which is, sorry, I should correct that. It's using a mixture of both the Mediasoup client API and then also what is a additional WebSocket abstraction that is created by the Mediasoup authors as well, that incidentally is supported by the SFU reference implementation. So a lot of this is pretty plug and play in terms of just grabbing the existing implementation and throwing it in. And so all this does is it does a quick signaling to negotiate the peer connection, or to provide the server and client with the necessary prerequisites for doing later SDP negotiation for these two peer connections we're going to ultimately need if we produce and consume. And so I just kind of wrapped them in a promise, and similarly so this is setting up the, I'll skip ahead, let's see. I'll have to check what that is later, but effectively this is, why is this in here? Sorry, I need to get rid of some of this stuff. This is not needed right now. I must have just cribbed that in. So anyway, this is creating the initial transport connection handler as well. So once it's connected, this promise will resolve. I believe that the connection logic here though is not ICE related. I have to double check that. I'm still kind of getting my head around the life cycle with this stuff. And then it creates a similar receive transport for incoming consumption of multiple media streams from other users, and a promise around when that's connected. And then I make the ultimate signaling request to join the room, and then I wait on the promises, and then I just go. These are just kind of similar things that we do in our existing driver to basically manage occupants and initialize any existing streams that may exist, that may have existed before the negotiation happened. So I'm far enough where that is all kind of seemingly working. Now, I can't promise this implementation is right because I'm still kind of just hacking my way through it. But you can see that if I, let's see, no produce listener. Oh yeah, that must be because I took that out. Okay, I'll just leave this for now. Yes, okay, so this event handler for the produce is necessary to signal back, to ensure that the signaling occurs on the server once the transport has fired its produce event, which I'm not totally familiar with what that is. And then this produce data bit, I'm gonna just drop this. This is the one I meant to drop. I'm not gonna implement data channels right now. There's a lot more meat to the thing if you're gonna try to implement data channels. Yeah, so Gabriel just asked that. I'm just cutting out the data channel support to start. We don't actually use data channels in hubs right now. Certainly it would be a natural thing to do right afterwards. I'm just trying to minimize the surface area of stuff I have to implement and keep the amount of code involved like small so I can try to keep it cached in my head. Okay, so basically so positional data of avatars is through the Reticulum NAF network layer, which is just TCP net WebSockets. So everything other than the voice and video goes through Reticulum's just basic Phoenix channel API. So I got as far as the audio going out. So come on. What's going on? Oh yeah, so you guys just caught me. I'm in the middle of implementing this routine. I'll explain what this is shortly. It's not working yet. So I got it far enough where it's sending the audio data. I'll also show off a little bit of a whiz-bang thing that's only in Firefox Nightly right now. It's in Chrome, and what it is it's called Opus DTX, and it's a fancy word for just basic silence detection. And so what happens is if your microphone is silenced, if DTX is enabled over the channel, then you will be sending like radically less data. That's been available in Chrome for a while, but now I was able to open up a Bugzilla and get it so that it's actually now also in Firefox, which is kind of nice, although it's only currently in Nightly. And so finally I got back in. So I just was kind of in the middle of some stuff. So you can see there's two negotiated peers. And so one of them is still dead because I'm not consuming anything yet, but then this is the producer peer. And so you can see that it successfully is negotiated, it's sending bytes. And so it's a little bit annoying because sometimes it's the first one or not. So you can see right now I'm sending quite a bit of data because I'm speaking, and you can see it's probably like 10K or so, 20K or so a second. However, if I mute my microphone, if I refresh, it's probably a little bit hard to read. Let me see if I can get it a little bit bigger. So you can see right now byte sent is like 240K, and now 242K, like several seconds later, 243K, like, good 4 or 5 seconds later. So you can see it's sending very little data now that my microphone is muted. And now if I were to go to do this in normal Firefox, not Nightly, then the amount of data going over would not vary very much if the microphone was muted and I was silent. So anyhow, that's enabled in the Mediasoup layer just via this Opus DTX flag in the codec options. However, what that does underneath the hood is it adds to the SDP a use DTX. I forget all the SDP terminology, but basically this is going to be an additional flag in the answer response that says that it's going to be using DTX. And then it's also disabling stereo, as you can see, which is something that is something we we don't need stereo voice because your positional voice is happening in the game engine, not through your headphones. So, so we don't need a stereo channel for this. And so that's the audio outgoing seems to be working. And so the next piece I'm working on is the video. And so the video producer code is kind of in place. So I have this little routine here that's just doing similar to the audio. The way the API works in these adapters is you basically pass it in a media stream. Yes, so DTX will be something that's available to anyone using WebRTC. It's actually not something that requires the server to have any capabilities. It's a mutually negotiated thing. It's basically an Opus concept. So the decoder and the encoder are the only dependent things. And if you're using Opus, which almost all browsers are, then if DTX is negotiated properly through the remote SDPs, then it will use the it'll have silence canceling or silence detection. So the API for the NAF Janus adapter and for NAF adapters in general is you pass it in a media stream for your media, and the API is set local media stream. And so now a media stream is a web browser API abstraction, and so it has tracks. Tracks can be audio tracks or video tracks. Incidentally, in our NAF Janus adapter, the way we handle this is when a media stream is passed in here, we loop over it, and because right now we can only send one audio and one video stream, we effectively do a diff and and replace or create any missing tracks in the any missing producer peers, or not peers, streams for the sender. And so we do kind of a similar thing here now. So I have this create missing producers thing. The Mediasoup API creates these things called producers, which abstract over a lot of complexity in terms of managing peer connections and all that jazz, and underlying streams in this case, because it's a unified plan negotiated stream or negotiated connection. And so it loops over these tracks, which are the tracks on the media stream that we're now going to be using. So right now, I'm going to continue with the assumption that we'll only have a single audio track and a single video track. That is something I think we may be able to now, if we do decide to go forward with Mediasoup and it works out, I think we can actually now start to send multiple audio or video tracks, which would be great. But I'm going to implement it as is, just to get it as close as possible to the current thing, so I can be sure it's one-to-one, and it'll be a little bit faster for me to do. And so I loop over all the tracks. I just kind of assume right now that we only want one mic producer track, which right now the only audio you're going to produce is your mic, and a video producer track. If there's an existing one, we just replace the track. Otherwise, we create a new producer for the corresponding kind of output. And this again is this is all abstracted away by the Mediasoup client API. So we're going to grab our send transport, which was that object I created in the initial join room routine, and that's effectively encapsulating the outgoing peer connection. And then I call produce, and what that's going to do is under the hood negotiate via SDP a new underlying stream for that peer connection, and then hand me back an object that encapsulates all that. And then I pass it the track I want to send and the codec options I wanted to negotiate for. And so, so I did the same thing for the video producer. I cargo culted this codec option thing. I'm actually not familiar with this, but one of the things is that I'm finding there's a lot of little bits about SDP negotiation that are present in the Mediasoup code that I haven't really seen before. For example, there's a lot of stuff around simulcasting, which I'm not familiar with. And so that might be something we might look into after this as well. But this is basically the basic negotiation for the general case that I saw when going through all the control flow. It just only sets this one codec option, and then other codec options may surface, or encoding options may surface if you're doing simulcasting, but I'm going to skip that for now. So now the next thing that happens is, yeah, so audio tracks, the biggest thing that I think we're going to use it for potentially, if we can do it, and again, I'm not sure if we can do it. I assume we can, but I'm not really sure because this is all very new to me, is we want people to be able to share their desktop audio without having to mix it on the client through a single audio stream. And so that way we could position the desktop audio on the screen itself in the room versus having it coming through the avatar. Right now, Kevin Lee is working on getting it mixed on the client so that we can do that, but it'll be coming through your avatar. And certainly we could eventually also support more sophisticated options like being able to stream multiple audio driver inputs into hubs as well. So that might provide a number of other interesting use cases, but overall, right now, I'm not really sure if that's a doable thing or not, but we'll see if we get that far. So basically, if I go ahead and I start streaming my camera, oh, actually, this is not going to work. Hold on. I'll have to stream my I'll have to stream a window on my screen because my camera is in use by the Twitch stuff. So the next thing I ran into is basically just another error, and so now you're finally kind of caught up to where I am, and so I'll just stream my terminal, and you can see what's going to happen is it's going to just be stuck here trying to do this, and the reason is because Hubs itself actually reads your own track in this case because it wants to show the screen, and so now I'm just kind of hacking out the next part of the APIs necessary to complete that cycle. So this isn't like a WebRTC thing. It's just that in the actual adapter layer, there's a map of media streams that we have, and these are actually the way that you would look up in the driver layer which audio and video tracks exist for each person in the room, including yourself. So it's kind of like the centralized place to go to get the media streams for everyone in the room, including yourself. And so in this case, that API, I haven't yet implemented it, or at least I've not updated this map properly yet to include my own stream. And so when Hubs is reaching in to try to grab it to draw it onto the camera surface, it's failing. And so if I look at the existing NAF adapter, there's a few bits of complexity here that I'm going to just skip over because I don't know if they're still necessary because of this Mediasoup driver providing some of the abstractions over this. So in the existing NAF adapter, there's this kind of centralized private function that you pass at a client ID and a stream, and that'll effectively register it into this map for that client ID. And you can set it for yourself, or you can set it for somebody else. So in this case, you can see we set it for somebody else here. That's in the add occupant handler, and then we also set it for ourselves after we join the room. And so we do a little bit of like ceremony here. So if a stream gets passed in here, we actually split it up into let's see. So yeah, we split the tracks into two different streams. And so this map is keyed on the client ID, which is, you could assume a session ID or client ID or whatever you want to call it. It's a unique identifier for this remote peer or ourselves. I think it happens to be the NAF network dayframe ID for the user, and then the values of it are this map of audio and video, which then move my head a little bit, which will point to the actual stream, which will be assumed to have a single track for the video and for the audio. Now, I don't know if this crazy stream splitting is necessary here. Actually, now that I think about it though, since these are streams and not tracks, I may just simply need to do it because I think this consuming API will obviously be expecting streams and may not walk into it. So let me just go ahead and I'm going to just check some of the call sites here. So there's this get media stream. Oh, this must be actually so we may not reach into the map from the outside. We must just call this API. And so it looks to me like probably I can get away with implementing just get media stream. I don't think set media, I think, like I mentioned, I think set media stream is just an internal function used to update that map. So I might actually do something a little bit different here. So let me just check. Okay, so that looks like it's not called. I doubt that it's called from network dayframe, but let me just check. Set media stream. Okay, so this is set media stream network audio source. This looks like it's just this is an incidental thing on a different component. Just happens to be named the same thing. So I'm going to actually change this a little bit versus how we do it now. So the way I was implementing this was kind of a little bit roundabout, but what I'll do instead is I'm think get media stream is probably the actual function I need. That's the public function. And so if I look at it in NAF adapter, it takes a type. I'm going to use the term kind because that's actually a more appropriate name for this. That's what the API in WebRTC uses. And the client ID is just who I want. Now in this case, what we did was we had this generic implementation that handled ourselves specifically, but I think it's actually better for me to just handle myself directly. So if client ID equals this client ID, which is going to mean that I'm myself, and then this will be looking it up, look up streams and map later once we get consumption working. But right now for production, we're going to just look at this. And so the return value is going to look something like this. It's going to be audio, and it's going to be an audio stream, or sorry, it's going to be a, let me see if it's actually returning. Yeah, it is returning a stream. So I could kind of like just create a stream here, because streams are pretty like lightweight objects. They don't really do much as far as I know. They just kind of wrap the tracks. I'm a little bit nervous about just creating a stream every time this is called. I don't really want to have that side effect. So what I'll probably do then is just, let me think. I may have to actually go back and do it the way it was effectively done this way. All right, never mind. I'm going to take back what I said. So I'm going to go back and I'm going to just do it the way they said it. So, or that we did it before. Okay, and this implementation is just straight up wrong. This is the one I was writing beforehand. So I'm going to grab this from set media stream, and I'm going to go ahead and I'm going to just grab the same code here, and this is going to effectively create 2 new streams. Set media stream, client ID stream, and it's going to really do the same thing. Now we have this promise thing that is going to sit here. This is the one that I also am not sure if I still need. This is effectively to avoid race conditions on where the stream comes in. I think it's around negotiation happening before or after the stream comes in. I'll have to check that later. I made a note to come back to that and just verify that the race condition either doesn't exist anymore or that we have to add the promise callbacks back through. So, okay, so this is not really anything new. I'm going to just do the same thing. The syntax errors here. No, this is just formatting. And so, so I have set my media stream, and that was the old function I was going to implement. I think what I'm going to do instead is just do kind of probably the same thing we do there. Is like this client ID and this local media stream, and then this is also, I'm trying to change these to be underscores because the existing code from the Mediasoup stuff uses underscores as a convention for the private variables, and so or not private variables, but you know, they're just marked as being assumed to be private, and so yeah, and so I'm going to just update that to do that. I'll also initialize it in the constructor. Okay, so now if I have my local media stream coming in, this is going to create all the missing producers. Okay, let me just see how we did it in AppGenus adapter. So it was actually a little bit weird because we did it. Oh no, we did the same exact thing. So we set the local media stream and then we call that routine to basically break it up into two underlying streams for that map. Okay, so let me just make sure this looks right. Client ID, it's going to take that, make an audio stream, just add the audio track, make a video stream, just add the video track. Then it's going to take this, stick it in this map, and then that's going to do that part. And then get media stream is the other piece. And so get media stream is going to, yeah, so this is the other side of that promise chain. And I don't really need, I'm not going to worry about it for now. So I'm going to just grab just the part of implementation that just is the happy path where it's already in the map, and just get rid of this. Maybe we do a to-do here. Come back later. Okay, and this is client ID, type equals audio, and now this is just going to do that. Grab it out. Oh, and this returns a promise. And let me just make sure I didn't do anything weird. Okay, so now let's see if that gets me any farther with regards to my video coming up when I and this is really not a WebRTC thing. I'm just kind of getting the full registration of my own streams with the driver so that the client itself can start consuming them. Oops. And this is basically a UI issue more than a networking issue. I think if I had the other parts working, I would go in the room and others would actually see my stream, but not, but I wouldn't see my own stream because this is like a special path. Okay, so let's see that. Nope, didn't work. So set media stream. I'm gonna do a little debugging. Let's just go in here, make this a little smaller, and then we'll refresh. And now I'm going to set a breakpoint on this set media stream routine just to make sure that, oh, I think I know the problem. Oh, never mind, no I don't. Okay, so look, in fact, let me just check something else here. There's a little bit of a strange difference in the semantics here. So in the old driver, we set the local media stream property after the streams are updated. And that might be intentional, so I'm going to go ahead and just refactor this a bit to have the stream as an argument, and then ultimately, yeah, and so create this, and then this will be like if this local media stream, this is just the initial startup case, so if there was already a media stream, a local media stream, it's going to also initialize it. That's like if you happen to have your track started already before the WebRTC infrastructure was running. So, okay, so now I'm gonna just do a debugger as well because I don't think this would have fixed this problem, but it's a little bit nicer now that local media stream will be set if and only if the underlying media stream registry has been updated accordingly and the producers have at least been kicked off to be attempted to be created. So let me go and do my debugger, dialog adapter, and then I'm going to just set a breakpoint on set media stream. I think right here is probably right. And now I should see this kick off here when I get my microphone set up. Let's see. Okay, yeah. And so I just want to step in here. So I usually use yeah, I don't know why this is not stepping in. I'm going to switch to Chrome really quick. Just bear with me. Find that the debugging experience in Chrome is a little bit nicer. Okay, so let's close all this. So I like Chrome's debugger a bit better. I mean, Firefox has gotten pretty solid, but it still has a little bit of quirkiness. And then on the Chrome side, I like Firefox's WebRTC debugger better. So, although it's in part probably because I'm not really as familiar with Chrome's WebRTC debugger. Let's see. Okay, so all right. So now it's complaining about this right here. Oh, this is just because I didn't update this properly. Okay, and so media stream. This all looks okay. Nothing like compiling code on a live stream. You have to just fill the air with something. Okay. So go full screen here and make it a little easier for people to see. So maybe just move my face. Here, I'm gonna move my face. All right, hold the power of technology. So now, if I go in here, everything seems to have gone okay. Let me just as a sanity check, make sure this is actually still broken. Let's do the tmux here. Okay, so we actually got an error here, so this is probably the first thing to check. So now there's a, that was weird. There we go. All right, so get media stream is failing on 139. This media streams, oh, this is just the usual fun of not being in a typed language, so I just had a typo here. Well, not really a typo, I'm just refactoring all of this stuff to the underscores, so that'll probably be a perpetual thing we're doing through this stream, is me forgetting underscores, but you know, I'm not writing TypeScript, so we're kind of just gonna have to roll with it. Yes, nothing like game development to make you appreciate the ability to multitask when you're waiting for your computer to compile. That's one thing I really like about web development, is that, you know, there's trade-offs, but it's really nice in terms of being able to have a faster iteration cycle, especially when you're talking about mobile VR development. I'd imagine it's gotten quite a bit better. Okay, we got some other bugs here. Get audio tracks of null. Okay, so stream, all I'm only calling get, I don't know why this is, it's really strange. 362 stream, set media stream, this local media, oh, I'm being silly. Again, this needs to be streamed here. Okay. And, but yeah, one thing that's been really cool is when you're working on like a mobile VR headset, having the ability to attach the live REPL to the thing is pretty nuts. Thanks. Yeah, we worked really hard on getting local development set up. I mean, we have the entire dev infrastructure there simply so that when you run npm run, it'll actually work. And so to do that, we actually had to parameterize all of our operations code so we could run multiple clusters and all of that. So it kind of had a pretty big blast radius, but ultimately it makes for a really nice setup. Let me just make sure there's no other errors here. Okay, and just as a sanity check, just to make sure I'm not going to just find myself back here again. So I'm going to look at the audio, outbound audio stream, packet sent, sending data. Okay, that looks like that's working. So I kind of expect this to still be broken, but now I'm at least able to work in Chrome for the debugger. So here we go. Well, I did fix a few bugs. So okay, here we go. Get video tracks undefined. 724. Oh, that's in media. It's in media views. So this is probably downstream from the problem. Let me just take a look at this code. So media views is our A-frame components for showing media in the room, and in this case, this is in the media video component. So okay, so it's just calling get media stream, and clearly that's not working. So oh, guess what? More underscore problems. Good times. Oh wait, this is the wrong code, never mind, sorry. Dialog adapter, get media stream, and now, okay, so that doesn't have a problem. All right, so I'm gonna just now do my debugging I was gonna do before. So let me go in and first I wanna make sure that it's setting it right. And so this is in NAF dialog adapter, and then in set media stream. And so I'm gonna just put a breakpoint here, make sure the variables are sane at that part. Okay, so I probably will actually see this when I'm doing the microphone, so I'm going to just skip over it for now and then put it back on. And then I'm going to share my terminal again. Okay. And now I get here, client ID is valid, stream is valid, I step in. Audio stream is there, stream get audio tracks for each. Video stream getting video tracks for each. So media streams, client ID, audio stream, these all look like valid values. Client ID looks correct. So now I'm going to set a breakpoint on get media stream. That's when it's going to get called here shortly. And then just continue. And now client ID is empty, which is surprising. Stream client ID. What the heck? Perhaps this is a problem. Well, so it looks to me like the URL we're attaching to the media view for the camera has an invalid URL. And so the way we actually, so everything that you see in the hubs room that's media has an underlying URL. And in the case of specific media streams that are like a user screen share or a camera, we do this kind of hacky thing where we create up this made up URL scheme called hubs : / and the idea here is this is a URL that's kind of an ephemeral URL that points to the video stream for a specific peer in the room. And so that kind of keeps the abstraction clean because it's a URL underlying everything. But in this case, we kind of dynamically handle it if we see the scheme that way. And so I'm going to go ahead and I'm going to just look through the code. I don't remember exactly where we inject that URL, but that URL certainly seems wrong to me. And so there might be some other problems upstream that are occurring that are preventing the URL from getting set properly. So I'm going to just go into a shell here and just go into hubs and then just prep for hubs that thing there. Oops, let's do this. So where do we, okay, so media utils, that's where we set the loader. Like right here. Now NAF client ID hasn't changed because that's kind of self-evidently part of the NAF layer, not part of us, or not part of the new adapter. So, let me see here. well, I guess I'll just try this for now. Oh no, actually this code is in, oh yeah, in media utils. Okay, let's just see what's going on with this. So media utils, hubs, I think I might be going down a bit of a rabbit hole here, but let's just find out what's going on. So the relevant code is in media utils, and so I'm going to pop that open, and now it's like on line 218, hubs. Let's do that, and so let's just see that at this point it's doing something reasonable. So if I go in here, what's it breaking on? Oh, it's breaking on the other stuff. Just bear with me. Okay, so now if I go ahead and share my terminal again, it's going to do that. Okay, so now it's nav client ID. Are you serious? Nav client ID is busted. I wonder if perhaps this is actually in the adapter. So I'm going to go ahead and perhaps nav is lying to a certain degree and saying that it implies to me that nav.clientID is just a dumb field, but now I'm starting to wonder if it's actually a dynamic property. So and in that case, maybe my dispatch to the driver is messed up for some reason. So so we go to here. Boy. So nav client ID. Yeah, it is a field. Network connection, nav client ID, connection, nav client ID, connect success. Okay, yeah, so it must be the driver now. So I have there's this connect success function, and that is a function that I touched on. Oh, haha, underscores again. Oh, sorry, I have to switch back. Underscores again. So, sorry, I was jumping around a bit. So I went over to the network data frame layer. It sets nav client ID based upon what is passed to the nav layer. Yeah, and it is just another underscore problem. So let me just do another search here. It's funny how, like, no matter what I do on these streams, I always end up having to deal with silly things like syntax or whatever. Okay, so now that should at least get the URL correct, and so, you know, I think the thing we fixed actually was somewhat downstream. I actually don't know what led me to realize I had to fix that first, because I think that it would have failed no matter what. Perhaps it was throwing an error somewhere in the get media stream, or set media stream rather. Okay, so we set it. I'm going to go ahead here. I'm going to get rid of this. I don't think this is the problem. And now I'm going to just make sure the call site here actually has the client ID now properly when I do a share. I'm not going to go so far as to just actually check the other stuff first, because I think it's kind of obvious what the problem was. No, okay, I guess I was wrong. All right, so let me go and let me just go to the dialog adapter again, and I'm going to just look for the connect success routine here and make sure that we're passing the client ID properly. Yeah, so we call it, so set client ID is called, or set client ID does set it correctly. So either set client ID is getting called late, or which is unlikely because it's just the driver is not changing the API or anything. Or this connect success is never happening. Aha, so that seems to be what it is. Okay, so if you remember when I was reviewing the code, I did kind of reveal that I was a little bit unsure about the whole life cycle of these things. And so I think this is actually an oversight on my part. So, okay, so like I mentioned, the transport stuff in Mediasoup is lazy, meaning that you don't actually start getting any WebRTC negotiation happening for these peer-to-peer connections until you send some data. However, the current driver, right, has this concept of whether or not you're connected and whether the scene is connected per se. And in the current driver and the current hubs implementation, we do all the WebRTC negotiation for the producer up front. So we actually negotiate, like the consumers are actually potentially delayed, or sorry, the initial occupants, if they're there, will also get negotiated, and we'll wait until both the negotiation occurs for the producer and also all the relevant peers that are in the room before we kind of fire this connect success. We call this connect success function. And so when I first wrote the new implementation here, I kind of had a working assumption because I wrote this part first before I saw anything else happening. And I kind of had a working assumption that I was going to do WebRTC negotiation up front, similar to how our current thing does. But in fact, it seems to not be the case. And so this connect routine, or sorry, this connect event handler, I believe is not firing until the initial data is being sent in the case of the send, or the initial data is being consumed in the case of a consumer. Now, if you go into a room and there's nobody in there, in fact, this event will never fire if nobody ever shows up on the receiver side. So what that means is that if my assumption is right, this whole approach I took at the bottom here, where I'm joining on these promises to effectively get the to the point where I can call this connect success, that is not going to work. So I'm kind of not sure what I want to do here. I think it certainly seems nice that you won't see the screen load in hubs until the SFU has connected to everybody. So really, like, what you would want to do here is be clever. You'd need to basically have this promise resolve much farther downstream if there's other people in the room, or you'd need to resolve it right away if there's nobody in the room. The catch, though, is that the producer side is very fuzzy. I really don't think if we can avoid doing any WebRTC peer connection setup for the producer when you're in the lobby, that seems desirable. And so that actually seems like this introduces a fundamentally conflict in the semantics. The question really boils down to, like, what does it mean to be connected to the scene? And currently that's one-to-one with, if you have, I mean, a number of things, but one of the necessary preconditions is that you've negotiated your producer peer connection, and we won't show the page until you've done so. But we currently do create that producer peer connection when you load the page, even though you're not sending any data. And so I'm kind of thinking through this now. I think I might want to just alter that contract. And now what I'll do, and we'll run with this and see where we end up, but I'm going to just effectively assume that we're no longer going to use peer connection negotiation as a prerequisite to consider the scene connected. And what that means is that you could see the scene load and you may see avatars talking, or our avatars moving around, but no voices yet. This may not be a problem if the negotiation is snappy. I kind of am cautiously optimistic that latency and negotiation will be radically reduced with this new adapter. And so I'm going to go ahead and just run with the idea right now that these peer negotiations, if they are necessary, for example, if there are people in the room, I will no longer consider them to be part of the set of states that need to be gone through to consider the scene connected. So it's a little bit like cheating, because I'm making it a little easier for me to implement here, but I think in practice it may actually be okay. So all I'm going to do is just drop this whole promise architecture I had set up, because these promises may literally never run in the case of the consumer, and won't run in the case of the producer until we start sending data over the microphone. So I'm going to just drop these. This is what I get for trying to be a little bit clever. This was not in the original implementation. I just kind of introduced this as a way to try to line up the connection semantics for network dayframe a little bit more nicely. Okay, so now what this will do is that these transport things will chug away here and just create the initial things, but won't actually do any underlying negotiation. Oh, let me just do this, callback, and then do this, air back. And so we'll actually get through network dayframe scene connection a lot faster now. However, it does mean that there may be scenarios where we either have people in the room, we won't be able to hear them yet, or if we did blow through the entry flow very fast, like for example, if you have the no entry flow flag on the query string, there might be a brief duration where your microphone is getting data, but you wouldn't be actually heard by others. I'm not too worried about it right now, because I mean, I think the latency involved for this Mediasoup stuff might be really, really low. And in practice, most people spend a little bit of time in the lobby just due to the fact that they click through, that won't be a problem. So it's mostly the fact that you won't hear others. You know, when you load the page, it could be like a second or two delay before we start hearing other people. But it might be nice to just get in there and start seeing stuff anyway before voices are picked up. So, okay, let's see. What is this complaining about here? Oh, just silly. Okay. Right. So now my assumption is that these promises are no longer there. And so what that means is we will much more quickly get to the connect success thing. Now, we do have an await on the join signal message, which is still, I think, the reasonable thing to do. I think we do the same thing in the Janus adapter. And so this means that we will ultimately have the connect success occur after the signaling occurs for the join, but not before the not after the peer connections are set up. Okay, so now let's see how far we get. So I'm gonna go ahead, application tmux, and this is my computer being slow. Okay, so we got some more errors. Invalid state track ended. Can't read property get. Let's see if there's more. Oh, there you go. Make this a little bit bigger. Await queue closed. Okay, I'm gonna start over here. Let me just see if the microphone is even still working with that promise chain I had there. Okay, so go ahead. This looks good. By the way, you may notice I have a debug flag here, and this flips on a number of debugging tools in Hub. So it adds collision visibility, and it adds a bunch of logging around networking. And so as part of this new driver, I tooled it out so that the logging was going to be extended if you have that turned on. I don't know why the logging just, let's take my thing here. Why is this acting funny? That was a weird paint issue. Okay, so, okay, now log is there. Okay. Oh man, my computer's dying here. Come on, let's see here. Wow, I can't even scroll. Okay. Let's see, let's get a stack here. What is this crazy await queue closed? So await queue is an abstraction that I noticed inside of the Mediasoup client code. So let's see. Now, unfortunately, this is an asynchronous structure, so we actually don't have a clue as to what the what's going on here, which is unfortunate. Let's see. So that is happening. This is just something else. I'm a little bit stumped here. Okay, so let's go back, and what I'm going to do is I'm going to drop the consumer transport first, just to rule that out as a problem, because we don't need it yet. It's just not a thing because there's no consumers. And then, so it's surprising. Well, okay, so what actually happened is by dropping that process, sorry, by dropping those promises out, there's a whole bunch of code that was, I thought was running here that wasn't and now is. So there's actually a pretty large surface area of potential problems that I may have just now exposed. So, okay, so we got an error right away. Man, my computer is just dying. Okay, here we go. Let's see. So, okay, it's still the same thing. Await queue closed. So, okay, so connect success. I'm gonna get rid of all this stuff because this is not, sorry, I'm gonna get rid of all this stuff. This is not needed yet. And now create missing producers. Let's get rid of this because I shouldn't have a local media stream during the join. So let's stop that. So really now the only change is that the onConnect success routine is called. And so in fact, we may actually be getting farther here. Oh no, because this is happening during the initial room join. So let's see. I think it is, right? Okay, so if I go ahead, look, I can't even scroll my mouse wheel. Come on. See, like my computer, I think is tapped out on memory. So let me see if I can kill some Firefox processes that might be floating around still. Nope. Okay. Anyway, let's see how far we get. Okay, await queue is closed. That's very strange. I'm gonna just do a bunch of undos just to stare at what I got rid of first. Okay, I'm gonna do a little trickaroo here. So I'm gonna go back. I'm gonna go back to my promise code that I had, which clearly was working with the microphone. And so I'm gonna just make sure that it still works, and then be a little more surgical in my change. I made a number of changes, so doing it more incrementally will probably help me understand a bit what I broke. Okay, so now the microphone's working again. So the first thing I'm going to do is pull out the thing that was busted, disconnect success thing. And we'll just see if now that the client ID is set, if I do that, if that does ultimately cause a bunch of other bad side effects. If not, then I'm a little bit stumped as to what surface area remains. If I had to guess, I would assume that this is going to cause the same problem for some bizarro reason. Oh, nope. Did it? Will my computer actually show me? Come on. Okay, yeah, so as I thought. Okay, so apparently if the client ID is set, there's other problems that occur. So, await queue closed. And so there's not going to really be a stack trace for this. That's really bizarre. So I guess there's places in our code where we depend on the client ID that were dark before and now they're not. And so that's exercising some bizarre stuff in the await queue, but I don't really know what. Let's see, execute task. Oh, this is a real head scratcher. Okay. Well, I only have 5 minutes on the stream. It'll take me a little bit of time to get to the bottom of this. So if there's any questions in the chat, I'm happy to answer them instead of you guys having to stare at me, scratch my head about what is causing this await queue issue. Most likely, I'll have to instrument the Mediasoup code a bit, and then see if I can get my head around it, because this stack trace is out of band, and so it's not going to be trivial for me to get a sense of what's going on. So let's see. Connect success. Let me just see. Is connect success? I see. So okay. So the it actually has two side effects. Connect success. It fires this connected event and it dispatches it. And it also says the client ID. So, so what I'll do is just as a quick hack, I'll just see which of those two effectively is causing the problem. Actually, now that I've looked at that, I suspect it's connected event because we do a bunch of stuff after the scene is connected to, and the previous version of the code clearly wasn't ever doing that. So now a whole bunch of connected handler code is firing that wasn't happening before. And so my guess is that that's causing some kind of bizarro side effect in the life cycle of either. So I mean, so the async queue, let's see, I don't know if it's changed. The async queue thing may be a bit of a red herring, because I did notice that the async queue, oh, no problem. I appreciate you guys watching. The async queue I've noticed was in the code for the Mediasoup stuff. But it is a pretty popular JavaScript library, so it's always good to check your assumptions. If I kind of assume that that was where it's coming from, that would be wrong, because I don't know that. I think it may be coming from there. However, because async queue is a fairly generic data structure, it could be actually coming from anywhere. The unfounded assumptions is the poison of programming. You can spend your whole day trying to debug something, but if you're not careful about the assumptions you had that led you to that, you could end up realizing you were completely going down the wrong track. Okay, so obviously the client ID now, I set it, and the nav client ID didn't break it. So I'm going to go out on a limb and assume now that it's the connected handler, because it's the only other piece of code that's not running. And so the way to go about getting into this would be to go check the connected handler, and I think there's actually just one place we do it. Let's see. Well, maybe we don't consume that. So let me look at network day frame. So it's connected, and then if I go to maybe network A-frame itself consumes it. So okay, so yes, so there's an on-connected handler, and that's inside of that's inside of networked.js, and so on-connected can be set by. Oh, maybe not. So on-connected is internal. And so, okay, so this code goes ahead and does a bunch of stuff with sets some stuff on the scene, because this is actually a network component on on the scene. And so this is setting the owner and creator on the scene, I think. Oh no, perhaps this is happening. This is actually something that occurs on the objects themselves. Yeah. This is not the system, this is the component. I think the system and the component are in the same file. Yeah, so it's a little bit hairy. So you can see there's a system networked, and I gotta make sure that the thing we're talking about here, the connected handler, is in the component, and it is. Yes. And so this unconnected handler, I guess, fires on every entity in the scene that's networked, and then when the scene is connected to. And so it's a little confusing because I don't think we actually have any. I didn't think we had any of those, but I guess we probably do. And so what it does is it sets the owner to be the current client, I guess, when you connect, and does a sync. Okay. That's strange. Well, I'm gonna have a lot of debugging to do to understand why this async queue is blowing up for some reason. Very strange, probably a long chain of logic to get there, but I appreciate you guys watching. You know, this is obviously a pretty complicated endeavor getting all of this stuff set up, and I'm gonna hopefully make some more progress today. And you know, the goal really here is to just get enough in place so that I can really deploy it to a test infrastructure, and then start hammering it with load and just take a look and see how it compares to the existing infrastructure we have and the existing driver and all that. So I think that's, you know, within reach in a few days, as long as I don't get really stuck on anything. But the nice thing is, like, all the code for this is really clean, and so I was able to get the basic examples of working on Amazon, so there's not going to be any like weird networking problems or anything like that. So it's really just implementing the code and getting it to start working with hubs. So maybe I'll be doing it more on Thursday. We'll see. Maybe I get far enough that I won't even be needing to do this on Thursday. But if I'm not there yet, I'll probably continue this Thursday. All right. Well, thanks everybody for watching. Hope you had fun, and I'll see you on Thursday. Bye.